Welcome to the course Digital Transformation and Technological Innovation. So, we are into our fourth module, that is Tech Advancement and Internet Basics. Specifically, we are into the Internet part of it. So, let us continue our discussion from where we left in the previous session. So, we were talking about the domain name system and why it is needed because humans can memorize domain names, but the machines need the numerical format for IP addresses, and DNS domain name system play that role, and in particular DNS resolver. So, we talked about that DNS resolver is the first stop which is typically managed by an ISP, and this will actually act as a middleman and will take the browser's request, and if it does not have the the numerical IP address for that domain name, then it will query the other servers to track down the IP. Now, this tracking down the IP might take multi-step process. So, after this first stop, if there is no mapping at the DNS resolver level, then we go to the next go up to the hierarchy, and there is root name servers that are there. There is another type of domain name server. Now, root name server, it represents the top level of the hierarchy. So, it does not know the exact IP, but it can read the web extension. For example, it would be .com or some other extension for that matter, and then it can redirect the DNS resolver to the correct top level domain server, right. So, once so therefore, next step would be that with the help of root name server, the DNS resolver now knows which top level domain servers it should query next, and then we come to the top level domain name servers or TLD name servers. So, these servers they manage specific extensions like .com, .org or .net. So, these are the different extensions that were identified by the previous step, root name servers, and therefore, hopefully the DNS resolver has reached the right TLD name server, and once that happens, then that correct TLD name server will point the resolver toward the specific server hosting the domain's records, right. So, eventually that information on the specific server which is actually hosting the domain's record, that will be there in the TLD name server corresponding to the extension, right. So, now DNS resolver in the next step can query this specific server, which is another type of DNS server. It is referred as authoritative name server, and now this is like a final authority. So, eventually if you did not get the conversion in earlier steps, then eventually you will land up at the authoritative name server, and you will get the conversion, you will get the IP address for the corresponding domain name. Now, this name server will actually have the official up to date database, right. So, therefore, for a given domain name, what is the corresponding IP address? It is likely to be here, and the up to date information is also likely to be here, right. So, for the requested website, it will have the up to date database. So, then it provides this name server provides the final IP address back to the resolver. Now, the resolver knows the IP address for that website that we were looking for, and therefore, it would be able to contact once it knows the numerical IP address. Now, it would be able to contact that particular server which is hosting the website, right. So, it will be able to reach or communicate to that server, right. So, this step of mapping domain name to actual the physical IP address, that might be a multi-step process, right. So, here is a demonstration of the same. Let us say this is your device, and you are trying to access, you want to check your mails, and you have an account in Gmail. So, you will try to and the URL of Gmail, which is mail.google.com, and now you want to access that. So, you are looking for IPv6 address. Google is IPv6 compliant. So, you will look for IPv6 address for this website mail.google.com. So, because let us say your device is new and it is not locally having that corresponding IP address for mail.google.com. So, therefore, your device will contact the DNS resolver, and if DNS resolver is having the IP address, then your device will get it, and then the next communication will directly happen with the Google's mail server, Gmail server. But let us say DNS resolver is that machine is also new, or somehow the that mapping is not there for that particular website, then this DNS resolver will track down the IP address for mail.google.com, and how it will do? It will contact the root server like we talked about. So, there is a root server. So, hey root server, do you know the IPv6 address for mail.google.com? So, in a way at a higher level this kind of communication is actually happening. Then root server will say that root server will not obviously have the exact IP address, but it will read the extension that it is a .com. So, it will give an address of a .com TLD server, right. So, it will send back that information of .com TLD server back to DNS resolver. Now, DNS resolver has another server to contact to get the IPv6 address for mail.google.com. So, this is what it will do. In the next step, that is step 4th, it will contact the .com TLD server, and it will again ask for the same IPv6 address of this mail service of Google, right. Now, TLD.com server, let us say it does not have that. So, it will say I do not know, but here is the address of google.com authoritative name server that can help. Now, it is Google's web service that we are trying to access mail.google.com, and it is the google.com name server that we have reached to with the help of TLD.com server. So, therefore, obviously that server will definitely have the IP address for mail.google.com. So, now the DNS resolver will contact the Google name server. Do you know the IPv6 address? So, obviously the Google name server will have the whole list of all the web services that it is providing. So, mail.com would be there, drive.google.com will be there, search.google.com, the list will go by. Google is running lots of services. So, this IPv6 address would be stored in some format, and then that would be returned, right, and by this Google name server, and therefore, it will come to DNS resolver, and the DNS resolver will give this IPv6 address to your device, and then your device will then be able to communicate using this IPv6 address of gmail.google.com directly to the mail server of the Google, right. So, this is here we have made assumption that your device is new, many things are new, and the mapping could not be achieved in the earlier steps. So, if that is the case, this is how the full blown process that takes place in resolving the IP address for a given domain name for a given website. Now, next is DNS caching. So, if we were to do the same process again and again in terms of resolving the domain name with the corresponding IP address, that will slow down the whole thing, right. So, therefore, the solution is DNS caching. So, DNS systems, they will be doing caching of these domain names and the corresponding IP addresses. So, what is DNS caching? This is a temporary storage mechanism that will save recently resolved domain names, recently resolved, right. So, which were the whole process was there, and updated IP address was recently obtained. So, it will be storing that information. So, there would be temporary storage, so that next device in the domain network does not have to go through the same process. DNS resolver will might have done the same process with a previous client, right, and for the other clients they might get that IP address very quickly because of this DNS caching mechanism. So, temporary storage mechanism, right, and the IP address is retrieved from local memory cache to load the website instantly, and because of this DNS caching, and that happens in the local machine and the DNS resolver and all that. So, this at times you will type a website and immediately it will load up. So, one reason for that would be that the DNS caching is working and the IP address for corresponding to that URL domain name is already there, and quickly contacts the server and downloads the page, and that website instantly loads up. That means when the process happens very fast, that means there was no DNS resolution for that domain name that was needed. It was already it had already happened by the same client machine, or by the DNS resolver in that network, right. Now, DNS DNS caching it avoids say multi-step journey, right. So, it avoids a multi-step journey via DNS resolver across the internet every time you click a link. So, for a given a link, because it was already resolved in previous iterations, so DNS caching will have that. So, therefore, that multi-step journey can be avoided because of the DNS caching mechanism. Now, there are certain issues, certain technical problems with the standard DNS, because standard DNS is quite an old technology, and when it was conceived, people did not imagine the kind of cyber attacks that are actually possible, and because of that new versions of DNS have come up. But just like the slow transition in case of IP address scheme, there has been a slow transition from DNS to the DNSSEC, that is improved version or the security version of, or the secure extension of DNS. So, what are the problems? So, let us look at the problems with the standard DNS. So, standard DNS relies on a blind trust mechanism. So, we notice the kind of steps that we talked about. DNS resolver is continually querying other servers and getting their response and using that response by trusting that response. So, in between, a cyber attacker might be monitoring the network, and it can monitor a particular message, particular packet, and therefore give a wrong response to the DNS, right. So, this blind trust mechanism will create a problem for the DNS resolver, right. It does no verification of who sent the IP. So, who is actually sending the IP, that verification is not being done. So, that mapping and the querying and the whole multi-step journey is actually happening at at a blind trust kind of format, right. So, what can happen that might result in saving a fake IP sent by a cyber attacker into its cache. So, therefore, DNS resolver might end up storing a fake IP, right. So, we talked about the temporary storage mechanism. So, some cyber attacker can monitor the network and manipulate the response that DNS resolver might get from different name servers, and therefore, that fake IP address will get stored in the DNS cache, and therefore, any new client, any new end user who is looking to access the website again might get redirected to a to the malicious website, the malicious website designed by the cyber attacker, and therefore, all kinds of data information stealing and all that can happen. So, there are lots of cyber attack incidents that have actually been reported in the past because of this, right. So, these problems, this problem related to standard DNS is something that needs to be resolved. Now, one solution or rather the solution that has been that is being adopted is DNSSEC. So, which is an extension of the standard DNS, right. So, what is DNSSEC? This is domain name system security extension. So, the security part of that was missing, that validation or verification that was missing, that is added up in this protocol, and DNSSEC is the one where most websites, most services need to transition to, right. So, this is a security add-on, and what it does, it adds the it is a security add-on that cryptographically signs the records to prove they are authentic. So, all the communication that is happening in terms of getting the actual IP address in that DNS resolution process, all those responses, they are to be cryptographically signed. So, therefore, the cyber attacker cannot decrypt them, and therefore, they will not be able to modify them. And the DNS resolver, it will know, it will be able to authenticate that, because it will know the key to figure out that the it is coming from the proper source. So, that verification part can be completed by this cryptographic signing of the records. So, DNSSEC provides that extension, right. So, it sort of creates a vertical chain of trust in the process. So, every step in the process this cryptographic signing is happening. So, there is a vertical chain of trust that will build up because of this. So, that cyber attack scenario that is linked to standard DNS and lots of incidents have happened. So, that can be addressed, right. Now, with that we move on to next aspect of our discussion, that is when we are typing a URL in the browser and we are looking to download a resource. So, how does this download part, right, how does this download part happen from the server to the client, right. So, we will now look at the mechanism of this download. So, there are two additional protocols that play the role of this download process. Now, we are going closer to the data level, the actual data that gets downloaded in the browser. So, we are moving our discussion is moving towards the protocols which actually facilitate this. There are two protocols, TCP and IP, which which facilitate this resource download part. Now, TCP, it operates below the application layer protocols like HTTP, SMTP, FTP, right. So, it operates below the application layer and it manages the transport control, and IP, it operates below the transport layer protocols. So, TCP, UDP, these are the transport layer protocols. So, TCP, UDP operate under application layer and they form the transport layer protocols, and the IP is a part of network layer protocol and it operates under the transport layer protocol, which is comprised by options like TCP, UDP and all that, right. So, now let us discuss what is the role of transmission control protocol in downloading a resource. So, this transmission control protocol is actually a connection oriented protocol, and this ensures that data is delivered reliably, error free and in the correct order across the network, right. So, because the resource that we are looking to download, it might be a huge file. So, it will not obviously be transmitted as a single file. So, and that actually transmitting of a file as a single thing will actually also jam the network, right. It will not be better utilization of network. So, essentially what is done, the data, it is actually broken down into smaller chunks. So, we will talk about that. So, when it is broken down in smaller chunks, those chunks need to be delivered in the correct order, right. Only then it can be reassembled back. So, the data that is to be downloaded, it is broken down, and then because it is now smaller data, smaller segments. So, it can be transmitted through the network and then reassembled back at the other side. So, it is a connection oriented protocol. TCP is a connection oriented protocol. Its main role is that data is delivered reliably, error free and in the correct order. So, there is no error in the data. In case through the network there is a loss or missing packets or segments. So, there should not be that should be detected and corrected, right. So, actual routing of the packets, that is actually done by the IP. So, transmission control protocol is actually doing the sort of managerial role in terms of managing the different segments of the packets that are arriving and assembling them back, breaking and assembling. So, that is the part ensuring that the data is complete in order and everything. So, it is playing more of a control role while the data is transmitted across the network. But actually transmission or actual routing of the packets, that is actually done by IP, internet protocol. So, essentially that is mentioned here that TCP manages the connection, it checks for errors and reassemble data if it arrives out of sequence. So, if there is any out of sequence, it will reassemble that, put it into a sequence. If there are errors, then it will request for resending that particular packet, right. So, TCP plays that assembly and reassembly and breaking the packet kind of role at both ends, right. Now, what are the distinct mechanisms of TCP? How does it work? Few more details. So, it is, as we said, it is connection oriented. So, TCP never sends data until it explicitly confirms that both the sender and receiver are ready to communicate. So, first there would be a handshake kind of thing where it has to be ascertained that both the sender or receiver, they are now ready to communicate. Once that happens, then the process will start. So, it will first confirm, it will do the handshake. It is a very connection oriented. So, that means first the connection will be established, right. Then guaranteed ordered delivery. Now, data is broken into, as I said, small chunks. So, these chunks are called segments at the TCP level, at the transport layer level. So, this is referred as segments. So, these are numbers. So, data is broken into small chunks called segments, and these segments are actually numbered. Now, using this numbering mechanism, TCP is able to guarantee ordered delivery. It will know when there is a error or missing segment, right. So, TCP rearranges segments into the correct order. So, once it knows that if there is out of sequence data, the segments have been received out of sequence. So, it will be able to rearrange that. That role is also played by the TCP. Error checking and retransmission, that is another feature of TCP. That means every segment contains a mathematical checksum, and that mathematical checksum would be used to verify whether the data is is complete, whether there is no error with the data, and so that part is also done by TCP. So, it does the error checking, and if there is any error found, then it will request for retransmission of that particular segment, right. So, in this fashion TCP is able to manage the error, detect error, get the retransmission done, manage the order, right, breaking the and reassembling all that part, right. So, TCP automatically detects a corrupted or missing piece of data using corrupted because the checksum did not match, and the missing because that particular segment, because it is ordered, numbered, that was not received. So, it is missing. So, it automatically does that part and might request sender to retransmit that specific piece of segment. So, these are some of the defining mechanisms of transmission control protocol. One more is flow and congestion control, because the data is being broken down and then reassembly is also happening. So, because of that the flow might get disturbed, because there might be some missing and corrupted segments also. So, it has to wait for that retransmission to arrive, and therefore, the flow can be disturbed, there can be congestion. So, the flow and congestion control mechanism is also something that is handled by TCP. So, TCP dynamically monitors network speeds, how fast the whole segments are moving, and the TCP will slow down the transmission rate to manage this this flow and congestion. So, it will slow down the transmission rate to prevent network crashes or dropped packets. So, if the network is slowest, it will adopt to that and it will slow the transmission rate, so that the crashing of the network or dropping of the packets that can be prevented, right. So, it will detect if a sender is flooding a slow receiver with the data, then it will reduce the transmission rate, so that is still a manageable connection is there, is still the service can be managed, the data can still be received in order, right. So, this flow and congestion control is also something that is managed by the TCP. Next is internet protocol, right. So, while the transmission control protocol, it covers the the both ends of the communication, right, assembly, breaking down the data into segments and then assembling and all that. The internet protocol is the one which actually manages the addressing and routing of data across the network. So, what is internet protocols? It's this protocol governs the primary set of rules on how data packets are addressed and routed across networks to reach the correct destination. So, we have earlier spoken about the IP addresses. So, essentially it is this protocol why the name IP where the name IP comes from. It is actually internet protocol address, right. So, this is the protocol which governs that, right. So, internet protocols essentially provides a way for computational nodes to identify each other, because each of the computational node will get an IP address, and using that this identification can happen, right. Then once the data is broken into smaller chunks, then the routing of those packets is also managed by the internet protocol, right. And the idea is, because IP address is there, so the packets reach to the correct destination. So, we can compare this with the postal service, where in the postal service we always have to write the address, the pin codes, house numbers and other things, so that our data, the physical data can be handled by the postal staff, and it can be sent to the right city and then right locality, looking at the pin code for the city, house numbers, etc. for the locality, and other details are there. Similarly, IP internet protocol uses the IP address to achieve the same thing, right. So, we look at the mechanisms to deliver data, the addressing part, as I said. So, every device once it is connected to the internet, it will be assigned a unique numerical identifier called an IP address. So, we were earlier talking about the exhaustion of IPv4 addresses because of the explosion of the devices and so many devices getting connected to the internet, and once they are connected, they will be given a unique numerical identifier, right. And because of that, because of this numerical identifier, this IP address, the computational nodes are able to identify each other, and this identifier sort of works like a digital street address, just like I talked about the postal services, and the pin codes and house numbers etc. are there to identify a particular house. Similarly, these numerical identifier in a way work like a digital street address, so that the computational node will be able to identify the servers and will be able to direct their packets to the correct destinations, right. So, this is addressing IP addresses. This is one important one important mechanism of internet protocol. Then the second is routing. So, in routing obviously you cannot send the whole file over the network because it would be too big, as we talked about. So, same applies just like TCP breaks the data into segments, the IP also breaks the data into chunks which are called packets, and each packet will actually have a header, and that header will have the source IP and destination IP, and using this information the routers that are there in the network, they will be reading the header and they will be routing the packets to the right destination, right. So, the first data is broken down to chunks called packets, and header is added which has the source IP or destination IP, which is like a digital street address which can be used to route the packet to the correct machine, correct computational node. So, the same thing is mentioned that network routers, they inspect this header, they inspect the header that is added by the internet protocol, and then they will get the source destination IP, and that information is then used to forward the packet along the most efficient physical path, right. Because the one idea is that end users should have a very good experience in terms of when they are accessing a website, that website should quickly load into their web browser. To give that good experience, it is important that the packets that are routed through the network, they follow a most efficient physical path. So, one role of internet protocol in the context of routing is that to figure out what is the most speedy or most efficient physical path for the packets to actually reach the destination, right. So, this is another important element of internet protocol. So, with this we have covered the important protocols that helps us understand that when we type a URL in the browser, what happens, how that page gets downloaded, starting from the DNS and TCP IP and other protocols that we have discussed in the earlier session, IP addresses and all that, and the breaking of data into segments at the transport layer and into packets in the network layer. So many things that we have talked about. Hopefully that creates the full picture for you. So in case what happens when you type a URL into a browser and how that page gets downloaded. So let us stop at this point and we will continue our discussion in the next session. Thank you.